Hi guys, I'm going to be totally honest with you here. I know this is 12.2, the converse of the Pythagorean theorem. But I think they're trying to make this out to be way more complicated than it actually is. Basically, all they're talking about in this section is how can I test if a triangle is a right triangle? So this is really what it's good for, is testing if a triangle is a right triangle. That's all this is good for. It gives you three sides. Well, yeah, I guess. It gives you all three sides. Sorry. So we are given all three sides. The largest number is the longest side. So that would be the hypotenuse, or C. Okay? You're given all three sides, the largest number is the longest side. So we use that as the hypotenuse, or we use that in place of C. The other two sides we just use as one is A, one is B. It really doesn't matter which is which. So the first thing that you do is you plug all three numbers into the Pythagorean theorem. Equation. So that is a squared plus b squared is equal to c squared. Second thing you do, you solve. You just solve it. And then the third thing, this is the important part, if the numbers are equal, the triangle is right. If the numbers are not equal, the triangle is not. It's either an acute or an obtuse triangle. We have no way of telling what type it is. This is just for, is it a right triangle or not? Remember when we were talking about the Pythagorean theorem, I said it only works with right triangles? Well, that's our testing, is to tell if a triangle is a right triangle or not. So pause it if you need to. I'm going to move on and do a couple of examples. First off, I'm going to give myself sides 2, 5, and 10. My largest side is the 10, so that has to be C. Okay? Largest side has to be C. I plug it in. A squared plus B squared is equal to C squared. 2 squared plus 5 squared is equal to 10 squared. You could have made it 5 squared plus 2 squared is equal to 10 squared. The only important part of it is that the C, that 10, the biggest number, ends up being the last number. That's the only thing that's important here. 2 squared is 4 plus 5 squared, which is 5 times 5, which is 25, is equal to 10 squared. 10 times 10 is 100. 4 plus 25 is 29. Is 29 equal to 100? Nope. So we know this is not a right triangle. Okay, let's try this one. 5, 3, and 4. The 5 is the largest number, so that is C. I do not care that the 5 comes first when I listed off the numbers. That makes no difference whatsoever. 5 is largest, so 5 is C. A squared plus B squared is equal to C squared. So I'm going to just go 3 squared plus 4 squared is equal to 5 squared. 3 squared, 3 times 3, 9, plus 4 squared, 4 times 4, 16, is equal to 5 squared. 5 times 5, 25. 9 plus 16 is 25. Is 25 equal to 25? Yes, it is. So this is a right triangle. This is literally all we're doing in this entire section. I do not know how they managed to spread it out over 3 pages. Okay? Yeah, that took us like 5 minutes to get through this part of it. So I'm going to go ahead and go through the pages in the book, but this should be a pretty quick lesson all around. Just a second. Okay, so let's work inside the book. I am on page 383. Verify the following sets of lengths. Make the equation a squared plus b squared equals c squared true. So we have 3, 4, 5. So we're doing a squared plus b squared is equal to c squared. So we first have 3 squared plus 4 squared is equal to 5 squared. 3 times 3 is 9. 4 times 4 is 16. Would you stop going out of focus, please? Thank you. And 5 times 5 is 25. 9 plus 16 is 25 is equal to 25. So, is it true? Yes. Does it make a right triangle? Yes. Next one. 5 squared plus 12 squared is equal to 13 squared. Get out your calculator. 5 squared we know, 25 plus 12 squared. I know what 12 squared is. Do you know what 12 squared is? 12 times 12 is 144 equals 13 squared. I don't know 13 squared right off the top of my head. 169. So 144 plus 25 is equal to 169. So that would be a yes and a yes once again. Next one. 7 squared plus 24 squared is equal to 25 squared. 7 squared, I know. 7 times 7 is 49. Plus 24 squared, which is 576, is equal to 25 squared, which is 625. 49 plus 576 is 625, equal to 625, so that would be a yes and a yes. Next one, 8 squared plus 15 squared equals 17 squared. 8 squared we know. 8 times 8 is 64. Plus 15 squared, which is 225, is equal to 17 squared, which is 289. 64 plus 225 is equal to 289, which is equal to 289. So yes and yes. And finally, the last one they give us is 20 squared plus 21 squared is equal to 29 squared. 20 squared is 400 plus 21 squared, which is 441, is equal to 29 squared, which is 841. 400 plus 441 is equal to 841, which is equal to 841. So yes and yes. There we go. That is the entire table. For each set of lengths on the table, cut strips of grid paper with the width. Yeah, I'm not doing that. For each, and try to form a right triangle. I mean, you can if you want to. I'm not. I just solved it this way. Based upon your observations, explain whether you think the converse of the Pythagorean theorem is true. I would say that yes, it is true because they line up. The squares, if you actually do cut them all out, all line up and all make right triangles. Make a sentence that's similar to that. Your 8th graders, I'm not actually going to write it down this particular time. I ran out of paper. So, or at least for this page. Let's move on to the second page, 384. Tell whether each triangle with a given side length is a right triangle. And so they show a couple of examples up at the top, one of which is, one of which isn't. So let's go down to the bottom to number 2, where it has 14, 23, and 25. So once again, we are using our a squared plus b squared equals c squared. So I have 14 squared plus 23 squared is equal to 25 squared. Let me do that. 14 squared is 196 plus 23 squared, which is 529, is equal to 25 squared, which is 625. 196 plus 529 is 725. Is 725 equal to 625? No, it is not. That is not equal. So that would be a nope. Not at all, not even close. Number 3 gives us 16, 30, and 34. So 16 squared plus 30 squared is equal to 34 squared. Yes, and you hear my cat Beetle with her little bell going around in the background. She's trying to see if she's going to go sit on the windowsill. That's where she normally is while I'm doing my videos. Okay, so I have 16 squared, which is 256, plus 30 squared, which is 900, is equal to 34 squared, which is 1,156. So 256 plus 900 is equal to 1,156, which is equal to 1,156. Agreed? Same number? So yes, that one is a right triangle. Number 4. 27, 36, 45. Dude, they're putting everything in order for us, aren't they? 27 squared plus 36 squared is equal to 45 squared. 27 squared is 729 plus 36 squared, which is my fingers, 1,296 is equal to 45 squared, which is 2,025. 729 plus 1,296 is equal to 2,025. Is 2,025 equal to 2,025? Why, yes, it is. So we get to put down, yes, it is a right triangle. Number 5. 11, 18, and 21. Once again, they put it in order for us. 11 squared plus 18 squared is equal to 21 squared. 11 squared is 121 plus 18 squared, which is 324, is equal to 21 squared, which is 441. 121 plus 324 gives us 445. Is 445 equal to 441? No, it is not. So we're going to put a line through that equal sign, and we're going to say, nope, not at all. Using it, remember to use the longest length. Oh, so they're going to give us some word problems for it. Okay, that's fine. A blueprint for a new triangular playground. I am jumping down to the bottom. Number 6. For a new triangular playground, shows sides of 480, 140, and 500. 500 is the largest, so that is going to be the C. Is it a right triangle? So I have 480 squared plus 140 squared is equal to 500 squared. Let's see. 480 squared is equal to, wow, okay, 230,400. 230,400 plus 140 squared, which is 19,600, so 19,600. People do 500 squared, which is 250,000. So 250,000. Let's add that up, shall we? 230,400 plus 19,600 equals 250,000. Are those equal to each other? Yes, they are. So is it a right triangle? Yes, it is. And this is your justification for it. Okay? That's what they want. They want the justification. How do you know? Well, that's how you know. Right there. That problem right there is how you know. Number 7. A triangular piece of glass has sides measuring 18, 19, and 25. Is it a right triangle? This is once again in order. So 18 squared plus 19 squared is equal to 25 squared. Let's see. 18 squared is 324 plus 19 squared, which is 361. Is equal to 25 squared, which is 625. 324 plus 361 is equal to 685. Is 685 equal to 625? No, it is not. So nope, that is not a right triangle. Number 8. A corner of the fenced yard forms a right angle. Can you place a 12-foot long board across the corner to form a right triangle for which leg lengths are whole numbers? Okay, so let's talk about this a little bit. It has a right angle already. It's asking, if I made this a 12, would these be whole numbers? Could these be whole numbers? So this is going to have to be a little bit of a guess and check, kind of. So I know it is a squared plus b squared is equal to c squared, which in this case is the 12. So 12 squared is 144. The question is, can I divide something out of that? That's going to, no, wait, that's not what I want to do. I want to see if there's any two sets of numbers that when you square them, you can add together to make 144. Okay, let's start with a, all right, let's see. How do I want to think about this? I'm going to do it this way, I think. And I'm going to use my pens instead of my markers for it because my pens take up less space. So I'm going to think about this for a bit. 144. If I take away from that 144 a like 6 squared. So 6 squared is 6 times 6, which is 36. So 144 minus 36 gives us 108. I don't know of anything that's going to give us 108. So let's not do 6. Let's do something else. 144 minus 7 squared. What's 7 squared? 49. So 144 minus 49 gives us 95. Again, I can't think of anything that would square and become a 95. So let's try 8 squared. 8 times 8 is 64. So 144 minus 64 gives us 80. There's nothing squared I can think of that'll give us an 80 as its answer. So let's try 9 squared. 9 times 9 is 81. 144 minus 81 equals 63. There is nothing squared that I can think of that will give us that. Let's try another one. 144 minus I'm going to skip over 10 because that would give us 4, because 10 squared is 100. I'm taking away 100. Let's do 11. 11 squared. That would be a 12, 121. So 144 minus 121 is equal to 23. Well, that's not going to work. We cannot go higher than 12. We cannot go 12 squared. 11 squared is as high as we can go. So I guess we should try out the rest of them going down. 5 squared, 144 minus 5 times 5, which is 25. I'm beginning to think that's absolutely not going to work, and we're just going to be stuck here. Minus 25 is 119. Yeah. Okay, so here's the problem. 121 is the highest square we can actually use. That's the highest square we can use, 121. Right here, we're at 119. If I go down to 4 squared, I'm going to go over the highest square I can possibly use. So I can't, so nope. There is no way those numbers are going to be whole numbers. They're going to be partial numbers. It's not that he can't make that a 12. It's that neither one of these, or both of them, cannot be whole numbers. So our answer for number 8 is they cannot both be whole numbers because $144 is not equal to 2 squares. Okay, so that's what I'm writing down for this one. They cannot both be whole numbers because 144 is not equal to 2 squares. Okay, so over on the guided practice, just a second, pause it if you need to. Okay, so we are on the guided practice. Number 1, Lysandra used grid paper to construct the triangle shown. I'm on page 386, sorry. What are the lengths of her triangle? So we are literally going to count the number of boxes she has. First number is 6. Second number is 8. And third number is 10. B, use the converse of the Pythagorean theorem to determine whether this triangle is in fact a right triangle. So B, we have 6 squared plus 8 squared is equal to 10 squared. That is what goes into the first set of bubbles, the first line across. Then we take the squares of everything. 6 squared, 6 times 6 is 36. Plus 8 squared, 8 times 8 is 64. Is equal to 10 squared, 10 times 10 is 100. You can hear my cat meowing in the background. She wants attention. I'll get to her in a second. 36 plus 64 is 100. So 100 equals 100. That is the entire set of bubbles going the whole way down for letter B. The triangle Lysandra constructed is a right triangle. Number 2, a triangle has side lengths 9 centimeters, 12 centimeters, and 16 centimeters. Tell whether the triangle is a right triangle. Number 2, A equals 9, B equals 12, C equals 16. Once again, we are filling in our bubbles. 9 squared plus 12 squared is equal to 16 squared. Now we need to square everything. 9 times 9 is 81. 12 squared is 144. And 16 squared is 256. So 81 plus 144 is equal to, 225. Is 225 equal to 256? No, it is not. So by the converse of the Pythagorean theorem, the triangle is not a right triangle. Number 3, a marketing team at a new electronics company is designing a logo containing a circle and a triangle. On one design, the triangle side lengths are 2.5, 6, and 6.5. Is this triangle a right triangle? Well, let's try it and see if it works. Number 3. 2.5 squared plus 6 squared is equal to 6.5 squared. I do not know what 2.5 squared is, and I'm not expecting you to either. It is equal to 6.25. Plus 6 squared, I do expect you to know that one. 6 times 6 is 36. Is equal to 6.5 squared, which I'm not expecting you to know either. 42.25. So let's add this together. 6.25 plus 36 is equal to 42.25. Is 42.25 equal to 42.25? Yes. And this is your explanation for how you know that it is a right triangle. Number 4, how can you use the converse of the Pythagorean theorem to tell if the triangle is a right triangle? Just a second. All right, so let's do number 4. How can you use the converse of the Pythagorean theorem to tell if a triangle is a right triangle? I probably already read that. So it ends up being, I can plug in all the numbers and see if the two sides are equal. Because that's literally all that we've been doing this entire time, plugging in all of the numbers and seeing if the two sides are equal. I think you can handle this. So yeah, that's really all that you need to do for this one. Okay, we're just determining, is it a right triangle using the Pythagorean theorem? I think you're good. Talk to you later. Bye.